to introduce him, at least in Belgium and in Europe, but I will still say that he's a physicist specialized in climate modeling. He's a full professor at UCLouvain in climatology and environmental sciences. He's also, very importantly, the former vice chair of the Intergovernmental Panel on Climate Change, so the IPCC panel, and he's a member of the Académie Royale de Belgique. And today he's here as a contrast, because we just had the biologist's viewpoint on the climate consequences on biodiversity, and now he's actually doing the exercise on the other way around. As a climatologist, he's going to talk about interactions with biodiversity, and I think this is like very courageous of you, and this is really what I expect we will manage to do today, so thank you.
Thank you, Caroline. Thank you, Caroline, and thank you for organizing this, and thank you all for your presence. Yes, I hope you're not going to be too unhappy about what I'm going to say. I'm in a very difficult situation because a previous speaker had a 1,000-page report to summarize, and I have 3 1,000-page reports to talk about, plus another one which is only 200 pages, so that will be a hard thing to do, but I will try. And I'm helped because I have a summary of my talk, at least part of my talk in my tie, which shows the evolution of the and the acceleration of the warming over the past 50 years. So I'll first talk about climate change. I know I have too many slides. All those slides will be available, so I will probably be very fast on some of them. But I have a 1-slide summary for the climate change part of my talk, which is the essential truth about climate change in 10 words. And I will illustrate some of those words in the coming slides. The first one is, it's real. Global change, global warming is really happening. The second is, it's us. Human activity is indeed the main cause, at least since the middle of the 20th century. Experts agree. There's a very large consensus now on the basic principles and on the conclusion that it's human caused. It's bad. The impacts are serious, are affecting people and ecosystems. But, and those are the last 2 words, there is hope, which is a word previously used as well. We have the technology, we have the knowledge, not only the technology, I would say, to avoid the worst climate impacts at least. We're actually very lucky in the solar system. We have a planet which is not too close from the sun, like Venus is, plus 500 degrees C, not too far, like Saturn, for example, minus 200 degrees C. We have an atmosphere which is full of useful chemical elements, but is very thin, as you can see here, and fragile. And it's really a shame, we're using this atmosphere as a dustbin for all greenhouse gases. And by doing that, we're actually thickening the layer, the thermal insulation layer constituted by those greenhouse gases, the main human greenhouse gas being carbon dioxide. And by making this analogy, which I would really like you to absorb and remember, that we are thickening a thermal insulation layer, it helps to understand, without any complicated equations or climate model, why we need, if we want to stabilize the climate and avoid excessive warming for everybody, humans and ecosystems, why we need as quickly as possible to reach 0 emissions. Maybe on a net basis, but essentially it means 0 emissions of CO2 in particular. Because as long as we don't reach that stage, we will continue to thicken this thermal insulation layer. I'd like to show it to you. Maybe there's a way to, no, it's quite visible. The projector is strong enough. So you have on the left the CO2 concentration increasing since the middle of the 19th century, 1850 approximately. On the right you have the temperature. We have gained, as was mentioned before, approximately 1 degree C already since the end of the 19th century. And we went from 280 parts per million of CO2 in the atmosphere to a little more than 410. And I like this presentation because even if the left circle doesn't show the planet, it suggests that idea of the thickening of a thermal insulation layer. They are both correlated. Of course, it's not enough to be convinced that one is the cause of the other. I'll come back on that. But it helps to understand the situation in which we are. Another way to see that evolution of that concentration is to look at the last 10,000 years, and you see that for 9,800 years approximately the concentration has been stable, and then over the last 200 years when we started to burn coal, oil and gas massively and deforest on a large base, on a large scale, the concentration exploded. So last May, when we reached the maximum value for the year 2019, we were at little more than 415 parts per million. Just 1 year before, we were at 412. So plus 3 ppm every year, between 2 and 3 ppm every year. That's the rate at which that layer is thickening. Actually, we understand quite well the carbon cycle, and this has been known for a long time. I'd like to show you a table coming from a scientist, an American scientist who died recently. It's a paper published in Science in 1975, and he tried to, Wally Broker tried to forecast the concentration of CO2 in the atmosphere in 2010. Remember, this is in 1975. And look at the number he got, 403 ppm, by extrapolating the amount of fossil fuel that was used at that time. So it was a big bet. And look what was the real value in 2010. It was 390 ppm, so quite close. So we understand quite well the elements of the carbon cycle. We also understand quite well the way the climate system responds to the increase in CO2 and other greenhouse gases in the atmosphere. You have seen some of those words in a previous talk, so I don't need to be very long. This is coming from the evolution of the IPCC reports, so the first one published in 1990, and to a large extent, it's not only from that, but to a large extent, it comes from two different attempts of reconstructing that observed temperature curve, which you see in black. The blue curve here is obtained by climate models forced only by natural factors, solar activity and volcanic eruptions. And the red curve is the average of the simulations obtained with natural factors plus greenhouse gases and human factors. And you see that with time, and each vertical line is a new IPCC report, the gap has increased, and it became increasingly clear and statistically significant that without the human factors, there was no way to reproduce the warming. And this is one of the elements of proof that humans are really the main cause since the middle of the 20th century at least. The consensus is very large. There have been a number of papers looking, it's a kind of meta-analysis, a paper looking at papers about the relationship between human activities and the warming, and you see the percentage of papers published in the peer-reviewed literature according to these different meta-analyses, and the percentage is in every case higher than 90%, and this covers thousands and thousands of scientific articles. Not only the average temperature which is increasing, it's also some extreme events, and the two categories of extremes for which things are the clearest at this time are the number of extreme hot days, like we had in many parts of the world last summer, but also heavy precipitation events, because as more evaporation over the ocean is possible due to the warming, a warm atmosphere can also contain more water vapor. When the conditions are met for that water vapor to condense, the amount of precipitation is larger. So we understand quite well what is happening, what has happened over the past 100 years or so. Let's look at the future. To look at the future, we have to use scenarios. For example, scenarios for the concentration of CO2. And these are the 4 key scenarios that the IPCC has been using. The top one is a kind of business as usual scenario, leading to approximately 1,000 ppm in 2100 by the end of the century. And the 3 other scenarios are scenarios which aim at stabilizing the concentration at a given value. The lowest one, named RCP 2.6, sorry for the complicated name, is a scenario which stabilizes the concentration approximately at the present level, approximately 400 ppm. By the way, the top scenario, which is the business as usual on which we are still right now, would, as I said, give us 1,000 ppm by the end of this century in 80 years from now. 1,000 ppm, and this is not climate science, it's medicine in a sense, is the level from which there is a direct effect of CO2 on mental performance, decision-taking capacity, problem-solving capacity. And this means that if we stay on the present pathway, this is not climate, this is just air quality. Fresh air, opening the window when you have the impression it's stuffy in a room, would contain close to this amount by the end of this century. And this will matter for everybody on the planet, wherever we are, because the CO2 is quite well mixed on the planet. This is unfortunately only one study in a peer-reviewed literature. It has not been reproduced properly by many other studies. It should be done, but I think it's quite interesting. So if you feed those, let's come to climate science. If we feed those CO2 concentration and other forcing factors scenarios to climate models, these are the kind of curves you have for the end of the century. For the business as usual scenario, you have an increase above pre-industrial, which is between 4 and 6 degrees C. And if you are on the lower scenario, you have a temperature which is approximately 1 degree above the present temperature. Of course, there's a distribution in space, and continents warm much more than the oceans, and also as you get closer to the polar regions, in particular the Arctic, you have an amplification several amplification processes which actually give much higher value than the average. And people and many ecosystems are based on continents, so the increase in temperature is much larger than the average. When you hear plus 2 degrees globally, it's actually much more over continents, particularly if you are close to the Arctic. This is the extreme highest scenario for Europe, for the end of the century, for the most sensitive model, for the top scenario. So this is kind of worst case situation, and you see increase of temperature above 10 degrees in those situations. We would also have, of course, changes in precipitation patterns. On the left, RCP 2.6, on the right, RCP 8.5, with many areas getting more precipitation, but also many areas, including the Mediterranean basin, getting less precipitation with many consequences for water resources, agriculture, ecosystems, hydroelectricity, wildfire probability, whatever. Climate change is becoming quite visible if you look at glaciers, for example. This is just one of the many glaciers you can look at, a glacier in Alaska, a picture taken in 1961. And now, a little more than 40 years later, from the same point of view, with the same type of lens, you see that most of the ice has melted. This melting of glaciers is one of the factors influencing sea level, but there are many others, and an increasingly important factor now is the melting, which is ongoing, of the big ice sheets in Greenland and Antarctica. We're probably above what I call the conservation temperature for Greenland and at least part of the Antarctic ice sheet. So we are at a very high risk that average sea level would increase by several meters over the next century or two. Right now, every day and a half, just Antarctica is losing this amount of water. For those of you knowing New York, Central Park is quite a big park, and the tallest skyscraper is quite tall. So the volume that Antarctica loses every day and a half is 1 billion cubic meter, which is water added to the oceans. So no surprise, the projections for the sea level by the end of the century are quite significant, plus 30 centimeters to 1 meter at least. Those were the numbers for the last complete IPCC report published in 2013. Now the special report on oceans and the cryosphere published just a month ago upgraded those numbers, and you need to add, not had the time to make a new slide yet, but you need to add 10 centimeters to the maximum approximately, and also you need to look at the text which says that higher values are not excluded. Imagine the consequences for people in the largest delta close to Europe, the Nile Delta. The red zone here was 20 years ago, when the diagram was made by Time magazine, an area which is 1 meter above the level of the Mediterranean, but also an area where 10 million people were living. We're going to get, whatever we do, at least 50 centimeters, half a meter, before the end of the century. So it's millions of people who will have to move and find another location to live and work, because they cultivate land there. If you don't believe that a few degrees can have such large consequences for the inhabitability of the planet, look at this representation based on many good geological indicators of how the planet looked like at the last glacial maximum 20,000 years ago. We have removed the clouds so you can see better. And there was a big ice sheet that is not there anymore on North America, another one that is not there anymore on Europe, Scandinavia, Siberia. There was so much ice there, 2 to 3 kilometers thick, than sea level were 120 meters. Excuse me, I'll drink a little bit. Lower than today. And if I show you this and remind, we understand quite well why this happened. It happened for astronomical reasons, which are fully understood. The reason I show this is that the difference in temperature between this state and the present state is only 4 to 5 degrees. So 4 to 5 degrees, which we could get by the end of the century, can have huge consequences in terms of sea level. Now, there are two good news. First, it took thousands of years to melt. That quantity of ice, so we're not going to get tens of meters in a century or two. That's not possible. But and also the other good news is that we don't have 120 meters left stored in those ice sheets. We only, quote unquote, have 75 meters for Greenland and Antarctica together. Now I'd like to maybe spend a minute or two on something that is maybe a little bit peripheral, but you will see at some point the link with the subject I've been asked to evoke, and that is the relationship between climate change and biodiversity. And we might maybe help a little bit to understand why the solutions to those problems are not advancing as quickly as what they should. US climatologists, and there are many wonderful US climate scientists, say this in Belgium, that net accumulation of CO2 in the atmosphere is so and so, and there is no quantitative explanation why this accumulation is so much lower than what the emissions are, and there is absolutely no reason to expect that existing trends between emissions and atmospheric buildup will continue in the future. Contrary to what you may believe, reading the IPCC report, the observations still do not confirm that human activities have led to any global warming. Projections are based on unverified models of natural and social science. Results from climate models are known to be wrong. It's impossible today to project future impacts of climate change, etc., etc. Well, maybe you guessed who that was, or at least for whom he was working. This was a climate scientist who is quite competent, actually, a physicist as well, who wrote several books which are used as reference by many of us, who was the main science advisor to Exxon, now ExxonMobil. And he was speaking to the Belgian delegation about to leave for the final negotiations of the Kyoto Protocol in 1997. And this was at a lunch event in the Federation, the Belgian Federation of the Oil Industry. The next day he was talking to 400 science teachers in Ghent, in the northern part of the country. Now, there's a reason actually to be very thankful to ExxonMobil, because they helped actually biodiversity to receive much more attention than it would otherwise have. Maybe you don't see what I'm going to come with, but Exxon also sent this fax to the White House in 2001, asking immediately after George Bush became president, asking the White House whether Bob Watson, who is someone you saw in a video in the first talk this morning, he was the chair of IPBES until 6 months ago, and he was then the chair of the IPCC. And ExxonMobil asked the White House whether Bob Watson, it's the same person, okay, could be replaced now at the request of the US, because of course what the IPCC was doing under his leadership was not a good thing in the view of ExxonMobil. And they were also asking the removal of other people. But actually, at the 1 year later, Bob Watson was indeed not renewed in his mandate. He was not re-elected, and it means he became free to work, for example, for IPBES a little later. So actually, you should thank ExxonMobil for doing this, because otherwise you would not have had Bob Watson chairing IPBES. So ExxonMobil helps biodiversity a lot. Now, joke aside, I think it's very important. I mean, some of you might think this is not the subject of the day. Yes, I think it is the subject of the day. A key reason why climate policies and climate measures, and I think probably very much the same can be said in the area of biodiversity, even if the mechanisms are not the same, is the fact that the industry, which has an interest in keeping the status quo, is spending huge amount of money to keep that status quo. And for the fossil fuel industry and the climate area, this has been documented. There's a peer-reviewed article, Broad 2014, in Climatic Change, which analyzed, thanks to the Freedom of Information Act in the US, very detailed financial information showing that the fossil fuel lobbies just in the US had $1 billion per year to sow doubt and disinformation about the issue. So maybe it helps to understand a little bit why things are not moving, okay? And it's probably not much better in Europe. But we don't have the same quality of data. I'd like to draw your attention to the fact that those merchants of doubt, this is the title of a famous book by Naomi Oreskes and Eric Conway, they've moved, they've evolved their arguments. They don't dispute anymore the existence of global warming. That's useless. I mean, if they still spend a little bit of their money on that, maybe, but it's not the main effort today, because everybody is seeing that the climate is changing. They're not spending so much energy anymore on disputing the human responsibility in the warming, but they always emphasize as much as they can the uncertainties around the science. They're still doing that at every opportunity, I can tell you, even within the IPCC when they have an opportunity. They always plead that we need more research before we take strong measures, and then they increasingly target their arguments on the alternatives, the cost of decarbonizations, the drawbacks from the alternatives, and there's an example here. I mean, this is an advertisement that I received on my smartphone just 2 days ago, showing by the same ExxonMobil how they are trying to plead the idea that we can actually, what is hidden behind what's written here is that since plants absorb CO2 naturally, what we just need to do is find the technology to emulate plants and absorb the CO2 that has been emitted by the burning of fossil fuel and deforestation. And the hidden message there is that we can still continue to burn as much fossil fuel that, for example, ExxonMobil is selling, and everything will be fine as long as we invent the technology to capture that CO2, and that's really dishonest. Let's talk a little bit about the impacts of climate change, and I won't cover the whole range because it would be a very long list. But heat waves, which are the clearest extreme event category associated with the warming, kill. If you look at these statistics from Shanghai, for example, showing the relationship between maximum temperature and mortality, you see that as the temperature gets close to our metabolism temperature, 37, 36, 37 degrees, the mortality, the daily mortality in Shanghai is multiplied by 3. And I don't know that the Chinese body works another way than the body of anybody else on the planet. There's also something, since we talk about health, that we need to keep in mind when we discuss health effects of climate change, and that is that air pollution kills every year 7 million people at the surface of the planet, including 500,000 in Europe. I mean, it's not only in India or China, it's also in Europe. And it's interesting because the sources of air pollution are broadly the same for air pollution and for climate change. And this is just one example of the many synergies that could be exploited much more in designing policies to fight climate change while addressing other problems, sometimes which have a shorter time scale than climate change. Now, impacts. I have to say a few words, even if you are all much more qualified than I am on impacts on ecosystem. And I just wanted to show something which has not been evoked up to now, and that is the marine biodiversity and the state of the Great Barrier Reef, for example. I mean, a full inventory made in 2016 showed that only 7% of the Great Barrier Reef had escaped coral bleaching. And coral bleaching, which is the first step on the coral death, if I understood well, and if I'm allowed to say it that way. I know there are many biologists here, so I'm afraid.
But the 10 billion absorbed by the ocean contribute to acidify the water. And actually, that acidification has been measured, and the projections for this acidification, if we stay on the business as usual scenario, are quite shocking. Look, this is a report, a reconstruction of the pH of the oceans for the last 25 million years. 25 million years. Look at the stability of this curve. I mean, some excursions here, but quite stable. And look at the movement here over the next 150 years. I mean, it's a huge shock, a huge shock for marine organisms who, of course, particularly at the beginning of their life, will have a hard time producing their shells and etc. In a water that's becoming more acidic. Actually, the IPCC produced a special report on the cryosphere and the oceans a month ago, and some of its key messages are that the ocean are indeed absorbing more than 90% of the excess heat accumulated because of that increasing insulating layer that I described at the beginning, and that this is starting to have large consequences for the quality of the environment in the oceans in terms of temperature, of course, but also in terms of availability of oxygen and nutriments. And the simple fact that marine heat waves are becoming more and more frequent is a big problem, which is causing shifts in fish populations, increased risk of nutritional health and food security problems. And the report also highlights the synergies, but in this case bad synergies, or the multiplying effects that effects from climate change and acidification on the ocean have, together with the pollution, for example by plastic, but not only by plastic, and marine life is under threat for that reason. That's one special report. Another one was already mentioned earlier, so I won't be very long on this one. But it's a report which was requested by the COP21, which adopted the Paris Agreement. And what the COP21 asked the IPCC to produce is a report looking at the difference in impacts between a warming of 1.5 degrees C and a warming of 2 degrees, because those two numbers are mentioned in the Paris Agreement in terms of goal. And the COP wanted to know what would really be the benefits of shooting for 1.5 warming, not exceeding 1.5 warming rather than 2 degrees, but also which trajectories in terms of emissions one would need to have to be on those trajectories. For those reading French, this is the reference.
But I'll give that reference again at the end of the talk. So the report came out with, of course, 1,000 pages, but some key numbers. For example, in terms of percentage of the population subjected to an extreme heat wave at least once every 5 years. For 1.5 degrees C, it's 14% of the world population. Just for half a degree more, it's 37%. But then there are also effects on the ecosystem and species loss. For vertebrates that lose at least half of their range. It's 4% for 1.5, and it's double that amount for 2 degrees, etc., etc. You have also those terrible numbers for coral reefs. For 1.5 degree warming, it's 70 to 90% of the world coral reefs would further decline. And for 2 degrees, they're basically gone, just for half a degree more. This has been expressed graphically, and we don't have the time to look at every detail. Those are the famous this is the famous burning ember diagram with the reasons, the 5 main reasons for concern, summarizing at the world level the key areas where there are reasons for concern, and the relationship between the colors and the warming. The vertical scale is the warming. This is where we are now, plus 1 degree. This is 1.5. This is 2 degrees. The first column, for example, is unique and threatened system, and the second one is extreme weather events. And the color scheme is a color scheme everybody understands easily. This has been done for a number of systems, including some ecosystems. I don't want to go through the details. Now, a few words about human activities. I would like to maybe put on the table a slight disagreement with something that has been said earlier this morning, and I felt some jealousy from the biologists, because biodiversity has not been as much spoken about as climate change. Yes, that's probably true, but look at this curve. Yes, there was a lot of talk on climate change, but look at the emission curve. That is what matters. So maybe we should reinforce our alliance, all those working on different silos in the planetary systems, and try to understand. And I think one of the things we need to work more is what I just evoked, with those deliberate efforts by the industry, by at least part of the industry, to slow down any change, while even though there's a lot of talk about climate change, there's a convention, there's a protocol, there's a Paris Agreement. Look, I mean, the emissions are still growing and it's almost a perfect exponential growth with 1.65% per year. So as long as we don't succeed going on the trajectory identified on the special report 1.5 I just mentioned, this is the trajectory which we should have ideally, and the zero line is here. The zero is here. It's that very thin line there. If we don't succeed getting the emissions to net zero means not emitting more than what natural systems, oceans and vegetation and soils can absorb, by the middle of this century, that is in 30 years from now, it's very quickly, then it means we will go above 1.5 degrees C. And of course, it would mean deep emissions cuts in many sectors, and it would have implications for food security, ecosystems, and biodiversity if we start to take carbon dioxide out of the atmosphere on a massive scale with artificial techniques. For example, what is called BECCS bioenergy, coupled with carbon capture and storage. It's a technique by which you use biomass to collect CO2 from the atmosphere, you burn that biomass to produce electricity, and you capture the CO2, preventing that CO2 to go back to the atmosphere. So this produces negative emissions. It's very nice on paper, but then if you do that on a massive scale, it means that all the area you use to produce that biomass you don't have available either for ecosystems or food production. So if you look at the effect up to now, and this is on paper, this is quite theoretical, of the plans assembled in the framework of the Paris Agreement, we would be there in 2025, here in 2030. It's a little better than the business as usual curve, but is so far from the 2-degree trajectory or the 1.5 trajectory. So the other special report that the IPCC is the third one. I'm close to the end of my presentation, that the IPCC finalized this year, last August. It's a special report on everything related to land, including desertification, land degradation, sustainable land management, food security, and greenhouse gas fluxes in terrestrial ecosystems. I will skip those slides because you probably know all of this much better than I do already, but as I said, those slides will be available. I mean, one of the messages that the IPCC report contained was that a move to more balanced diets comprising less meat, red meat in particular, would help, but we all know that, I think. A few final words on hope, maybe. Maybe there's some hope coming from the fact that there are some bankers and some investment people who are starting to understand that there's something wrong in what's happening. And while they were sleeping, when ecosystems threatened were mentioned, when one talks about threats to the economy, they start to wake up, and they start to remember that in the EU we use €1 billion every day just to buy fossil fuels outside of the borders of the European Union. It doesn't even include the Polish coal here. Just to buy fossil fuel outside the borders of the EU. €1 billion per day. So that's a lot of money which could be used another way if we had another system than using fossil fuel to fuel our economies. And this is a slide. Probably the numbers would need to be updated a little bit. It's a slide coming from the last full IPCC report in 2013-2014, showing that ambitious mitigation that would put us on a 2-degree trajectory, that was the target on the table then, would actually cost very little in terms of percentage of the GDP, and it doesn't even include the benefits of reduced climate change. Hope, yes, we have the Paris Agreement. It's a framework. It's a very useful framework. We have the Sustainable Development Goals. We know, and that's another part of the special report 1.5 degree, that there are many synergies. The synergies are in blue on this diagram. I know it's unreadable. What matters is the color. You have the 16 other sustainable development goals than climate change, which is SDG number 13. And what the columns show is for energy supply, energy demand, and land, the trade-off in brown, the synergies in blue, green. And as you can see, there are many more synergies with all the SDGs, particularly for energy demands, than there are trade-offs. Of course there are trade-offs, but there are many more synergies. So if we could really use what is recommended in the last report, and this is only 200 pages and just came out a few weeks ago, the future is now Science for Achieving Sustainable Development, the Global Sustainable Development Report 2019, which pleads for a much more holistic approach to the SDG and for exploiting much more the synergies between fighting climate change and looking at biodiversity at the same time, and looking at gender balance, and looking at fighting poverty, etc. We could do so much more. I will skip these because it's too long. you'll have to read these yourself. These are scenarios which are quotations. I didn't change a single word. I just shortened it by removing some sentences. 2 scenarios contained in the explicitly with those words in the special report 1.5. And you can see that those scenarios are very different in terms of consequences for ecosystems and humanity. We have the choice today to go one way or the other. And my last reason for hope is something which has been mentioned earlier by the first speaker, is the youth movement inspired by Greta Thunberg, who is attacked in a very dishonest way. I wrote a letter published by Le Monde in French, and I published a translation in English as well if you're interested. Those are the website where you can find my slides, and therefore also all those other websites. The only website to note maybe is the first one. Thank you for your attention.